discuss. But yeah, I'm very happy to share my the work and the research recently, which is talking about the cybernetic humanity. I will present here, and in this coming one, let's say 1 hour, I will less than 1 hour, I think. Like I will talk about my research and then hope you this give you some inspiration and also some interest in the XR and the AI research field. Right. So then the topic is cyber humanity is talking on the rethinking about how we can define the new humanity and the new self from the emerging self from the human computer integration. That's my topic research. And then let me a little bit introduce myself. My name is Shunichi Kasahara. Then I'm a researcher in the Sony Computer Science Laboratory, and also I'm leading the Cybernetic Humanity project. Then as a sorry, give me a second. And sorry, and my activity is actually coming from the three pillars, which is the researcher. So I'm researching about human augmentation, human computer interface, the human perception and cognition, and also self in human computer integration. And also, I have a kind of like a background of the engineer, which is like a development of systems, the interactive systems, and of designing the system architecture. Because I have a partially before joining the Sony CSL, I was in the Sony headquarters, and I was working as an engineer there. So I have a kind of an engineer background. And then as a third pillar, I am also working as an artist, which is making some research into more societal. Sorry, I have sorry. So to get like a more society collaboration and also like getting some society involved in the research cycles, I was also doing some artwork for, make people experience our research and then getting some like insight and also observation from these kinds of activities. That's why also I was working on the artist from based on the research. That's my three pillars. And again, that's kind of research topic and the theme of the research, our research group. And basically, I'm here. This is a description. So, computer no longer are just tools for humans, but are deeply intervening our body and behavior. So, when humans integrate with computer and acquire new abilities, different bodies beyond what we currently possess, then how we can define ourselves and how we can define our humanity? That's a question. Then, because like when we think about like okay, so new technology, we can also augment myself and integrate with computers, right? Then we can do many things. But once we cannot feel this is myself, right? In that case, this is actually quite disaster because it's gonna be more like for losing ourselves. Even we get some new abilities, even we get some new bodies, virtual reality or some like robotics bodies, but if we cannot feel this is myself, this is more like for computer. Actually, computer technology will, you know, um, we lose some of our identity, we lose our subjectivities. So how we can balance, how we can kind of the leverage of those technologies, enhancing and also embracing the human nature and humanity. That's a core question to my research. So, like today, I will talk about several aspects from my project, and they're mainly coming from the action, body, identity, and interactions. So, I will go through the one by one. So, first of all, I want to talk about like starting from the talking about the actions. The mainly action feelings like a sense of this is my action. So in the psychological the term, we say this is sense of agency, which is the feeling of that this action is caused by myself. So for instance, right now I'm talking myself, and then I'm using my voice, and then I am also controlling my mouth. This is feeling of my agency, right? So I'm moving this mouse. Hope you can see my mouse cursor because I'm moving my cursor. This is my actions, right? But what if computer and human integrated. In that case, like those kind of, I am moving my hand, I am moving my cursor. That's simple, but in that situation will be not always true once computer human integrated. So I will show some example. So then let me, so I want to start with a very simple example of the human computer integration, which is actually done in the almost like a 2000, in the 2017 with the collaboration with Nishida and also Ken Suzuki. And then if you have any physical interaction in together for you guys in the winter seminar, maybe you have some chance to, physically face to face. And then in that case, please try some simple demonstration, something. So let's imagine someone have a pen, something like this, right? You hope you see. And then someone have to catch the pen by releasing after someone release the pen. That's a very simple one, right? Right. So but even it looks like a very simple, it's actually very quite hard. So let me show. For instance, without any usual human nature, it's quite difficult, as you can see. But once we equip something like this and then connect to something, let's see how it looks like. Sorry, it's play again, maybe. Right, right. Oh, give me a second. I was jumping to the wrong page, I guess. All right. As you can see, they can catch a pen. They can catch the pen very easily. So what happened and why we could not catch the pen? Because we have a lot of latency of the visual perception, cognition, in the motor plan, which is like okay, so actually we perceive the light from our retina and then everything in the cognition happened or like they found like, oh, he is opening his hand and the pen is going to start to drop. And then he or she start to thinking about like a motor plan to the actuating the hand, and then all of the motor signal goes through the spiral cortex and then go to the muscle cells, and then finally it's firing the muscles, and then the contraction happens, and then they can catch the pen. So, but in the total processing, it actually takes up 250 milliseconds, which is actually quite long. That's why usually in our naked body, we could not catch the pen. We cannot catch the pen. That's actually our human limitation, basic human limitation. And then the video just I showed is actually we actually using EMG, which is electromyography, the sensing, detecting the muscle activity of the people who are release the pen. So it's detecting the moment of the person A is going to open his hand or her hand. And by using that signal, also we put the electrode into the person B and applying electromuscular stimulation, which is EMS, is actually applying current into your body and muscle and then contract your muscle by means of the electroshock or electrostimulation. So that's why in the previous video that they could catch the pen. So in this initial our exploration, we actually like demonstrating these phenomena and the experience are like, okay, so in this system, the computer assists you to catch the pen. It's more for computer is forcing you to catch the pen, something like this. Then this is a demonstration of the video, for instance.
I initially felt like
All right, so as you can see, like she can catch the pen very easily. And in our initial experiment, or initial exploration, we are kind of happy like, oh, we can make people to catch the pen, and then that's it. And then we actually can demonstrating these things in the C graph and the other like many conferences. But one day, or actually many persons started to say something interesting. So I will show another video from here. This video, in this trial, in the first trial, I I didn't turn on the EMS, so no EMS. The second trial, I actually secretly turn on the EMS, right? So let's see. No EMS.
Oh, you
I have
really
good
faster.
reflexes for an old man.
Right. So like it's like a second trial, he could catch a pen, and then like he said, "Oh my God, my reflex is very fast." And then because like he said like because I'm always training myself, that's why my reflex is very fast. But I actually explained, oh, sorry, gentlemen, this is because of the EMS. This is unfortunately this is not your ability because of the EMS is makes you the catch the pen. But he didn't like he didn't listen to us like oh because like oh no I think like I did it and then like it's because I'm training myself and my reflex is not so much bad on me. But at that time like I was a little bit sad because like nobody listened to my explanation. But I eventually many people started saying same thing like something like this. They feel like oh I could catch a pen. But in the system or like a timeline point of view, actually the EMS comes much faster than they can do, and then the muscle contraction happens even before they can do, but still they feel this is my action. So we actually find like this is quite interesting phenomenon because like even we are actually augmenting the reaction time response, but still they feel this is my action. So then we actually investigate, okay, so like what is the kind of best point? What is the kind of time course, the trend of the feeling sense of agency, which is this is my actions, and then by changing the time of the EMS. Then this is like a paper from the 2020. 19 and with collaboration with the June and Pedro this is the Kai 2019 and then we actually create like a very simple kind of like a psychophysical experiment, which is like if you see some like a black dot, please touch the touch screen as much as you can. But also we apply EMS in the many various timing of the same hand, same finger, right? And something like oh sorry maybe like right, and it's something like this. So if it's quite fast, so let me play it again. So you see the target, you see the target, and then touch it, and then also almost like the same time of or slightly faster or slightly slower, EMS also comes in, and then you touch, or maybe EMS forced to touch the screen, and then after that you answer the how did you feel, how much do you think you did it, and then questionnaire, then 1 to 7. And after that, like after getting the lot of data and aggregating the analysis, we actually find even we accelerate the reaction time 18 milliseconds faster, they still feel over 15%, they feel this is my action. Which is like they have some like a they have some like a time window, which is still they feel this is my action, even their finger, their muscles is actuated before they started, right? So this is a time window of the keeping sense of agency, even in the kind of preemptive, preemptive actuation of the muscles. And all right, so then like a bit from this point of view, like once we design this kind of augmentation system or like an acceleration system, we can also make the people feel like, oh, this is my action, even they are like actuated by EMS and keeping sense of agency. And the more like a broader point of view, this is also something like the schematic, which is because like in the white line, usually we have some input from the many kind of sensing organs like a eye or ear or touching or something, and then we process and then decide something, and then execute our actions. But in the human computer integrated situation, we actually the computer is also behind our brain and the cognitive process, and then eventually, like by using EMS or other technologies, we can also create like the integrated action, which is not only by myself, but also computers. And then the important question is that even these kinds of integrated actions, how we can attribute this action outcome or action itself to ourselves to preserve our self-attribution. That's a kind of core question. And when we think about human-computer integration, then we so like based on this like EMS experiment, we also did some like following up and also successful research about like preemptive action or EMS actuation from the sense of agency. So I will not go deeper in here, but the one project one project is more like for once we have the cognitive de- cognitive decision, and then even that the EMS is also actuating your muscles. What happens? Or keeping agency? How the keeping agency impact the adaptation and also learning of the movement. It's actually the keeping agency is actually beneficial for learning and also training yourself actually. So we also like published some two papers after this kind of project in 21 and 22 and the Tukai and the Kai. So if you have any, just please check. And also like based on this kind of integration idea, we've been working on the several, also not only the EMS, we've been working on the several technologies by electromagnetic actuation or robotic movement, robotic body, and also interpersonal interaction between human to human. Sorry, I little bit. What? And also like kind of like using computer human integration for the teleoperation and also telemovement, and then also like a electric magnet actuation hand exoskeleton, for instance. Like we've been working on kind of like the human augmentation, still keeping sense of agency. So, right. And then so recent activities on these topics, we actually also showed the Agilin, which is kind of embodied agile robotic arm, very fast moving robot arm by integrating digital reflex and then also enhanced reduction, which is also we present in the Sigo Asia last year. And then which is a collaboration with the Ryuya Niyama in the Meiji University. So because we can also think about like, using robot arm as own bodies, right? Then but for instance, we can also imagine like, we can create, you can using this robot on my own bodies and then much faster and then for instance, much accurate, for instance, then, right, something like this. And then we actually did some like a human computer integration, something like this. So for instance, you might see in this video, the people is using robot arm as own bodies and then shooting something like this. So usually, if you want to do something, it's quite hard. Even in the human bodies, it's almost impossible, right? And then also in the when we think about controlling robot arm from the teleoperation or something, it's almost hard to creating this kind of the precision. But in our system, it's actually in the integrating human motion and also the computer automation, which is like if we kind of observe human intention, then here more like for targeting some like this kind of bottle, and then we analyze these intentions, and based on the intention, we actually integrate human motion and also computer motion. Then it feels like we can also create kind of a very high precision movement, but still he feel, oh, this is my action. I shoot this ball, something like this. And applying these ideas, we can also create sense of the accomplishment, and by using the kind of like integrating AI motion, for instance, let me show this video. The first video is actually without AI assist. For instance, he is using this robot arm to doing some like baseball experiment, but then unfortunately he could not hit the ball or something. So he's kind of like a little bit hard. But now you see it in the with the AI assistant, as you can see, he's actually maybe like let me show again. Hope you can see the video in smoothly. Double check. Like I will play again something. As you can see, that he's kind of like he feels like he could hit the ball. But in the reality, in the inside, so we actually can creating a system like detecting the moment of the he's trying to hit. And in that moment, we actually can intervene and also create a mixture of the movement of the human movement and also like automatic movement, and then like make it possible to hit the ball in this kind of very fast movement, something like this. And the important message here is actually like because in the before he shoots the ball, maybe you might see. So he's waiting motion. He's still this motion is still very intact and very highly correlated, right? That is actually important because this is also giving you a sense of the embodiment and also like a movement and my movement also robotic movement is correlated in a sense of this is my bodies. But only moment of the targeting the object and also kind of like doing some hit motion. We actually can assume that he's doing this action and then aligning this his intention, we can create some integration. From this point of view, like understanding human intention, based on the human intention, we actually create like AI assistant, more like for new, kind of like kind of harmoniously integrated with human actions. That is, I think we think like this is very important to keeping like a sense of self or preserving the self contribution. Right. So like that's the kind of recent activity of the human, kind of like a human AI integration for still keeping sense of agency in the human AI computer integration. So like from these lines of research, we also actually we also find like this is quite interesting like a time course of the having experience. For instance, like as I show, like there are some time window for subjective experience as a self. Like even there are some like intervention or some acceleration, we still have some like capability of the feeling this is my action. And also like in this like a kind of like a central nerve brain to bodies, we have a kind of a delay over the neural circuit and go to the nerve pathway. So for instance, like I can kind of brain to actual body's movement, it actually takes up more like for 15 or 14 milliseconds, right? And then that's actually a very interesting phenomenon or kind of situation happening in the network. For instance, like now in the when we using some internet is actually getting super fast right now. And for instance, in the Tokyo and Osaka, for instance, is the next city of the big city in Tokyo, Osaka. It's actually the Tokyo, Osaka, it only takes like a 10 milliseconds, for instance, 10 milliseconds, which is actually faster than brain to body's movement. It is actually. And also more interestingly, like for instance, in the recently the study, which is like by Elon Musk, they are using some satellite internet connections, and then in the Starlinks, their target is actually creating the internet latency in any of the place in the Earth. They are trying to make it less short, faster than 20 milliseconds. So 20 milliseconds, which means like because like we have some latency for the neuron to the bodies, it's more like for 50 milliseconds, but internet latency is 20 milliseconds, which means is actually network speed will exceed the human neural speed. So that's a quite interesting phenomenon and also situation because like that means like when networks exceeds the human neural speed, it's actually network all over the network will almost comparable of the human network, right? Human neural network, which means like when you think about like the kind of like the robotic body or other type of the virtual body, something, and those kind of latency will be less than our naked body's latency. So in that case, for instance, if we want to do something, we can also feel, oh, this is my action, this is my body, even in the like for instance from the Tokyo to New Zealand or something like that, in the even the very first place, we can still feel, oh, this is my action. So I think that's kind of next interesting phenomena when we think out of body and then existence. And then we are now kind of working on this kind of project in the government funding project, anyways. So we are also working on that, right? So that's kind of the action and also bodies. And then also like I also want to start with talking with about the bodies. But it looks like I actually running a little bit time, so maybe it's a little bit. Let me skip some slide, maybe. Uh, then I actually want to jump into the another topics of the identity. All right, sorry. So you can also still find my other projects in my website. So if you have any question or interest, please check. And I will talk about the identity.
Hello everyone, I am Shun Kasahara from Sony Computer Science Laboratories. Today I would like to introduce my research on cybernetic humanity, exploring the self emerging from human-computer integration. Computers are no longer just tools for humans, but are deeply intervening in our bodies and behavior. When humans integrate with computers and acquire abilities and different bodies beyond what we currently possess, how do we define our own humanity? This is my central interest.
So that's my presentation, but it's actually that video was AI generated. So like I mean, you might find like my pronunciation and also like English pronunciation is actually much better than actual myself. So this is sometimes I feel like I'm a little bit sad, and then I even feel like, oh, maybe like I can just like let him do my presentation instead to myself. But yes, like in the previous video is actually recording my body videos, and then train the AI system, and then instead to myself I actually generated my data video, something like this. And then that's actually so that's also telling us like that's quite interesting phenomenon and also error because of the vanishing boundary of the self and AI. So even still me right now, I'm using my own physical body yet, and then I am presenting my talk by myself yet. But we can also easily imagine like instead of myself, AI clone or some AI generated myself can do that, something like that. All those kinds of things, like in that case, do you think still this is me or not? And then how we can like those kind of identity and the facial things is actually kind of fragile and also like a kind of varying, very changing. So like to understand these kind of the sense of self and what is the kind of boundary of self and how we can define this identity is quite important in the area of the AI integrated. So this kind of aligns with the research questions. We've been working on the several research of the identity. For instance, like the one example is from the kind 23 that is morphing identity is the facial morphing systems, which is the two persons coming to the booth and then taking some photo booths, but then two persons actually can talk each other in real time, something like kind of like a Zoom system, right? But while they are talking in the Zoom or some just kind of having a conversation, you might find, hope you can see the video in smoothly. You might find like those two persons' face is actually swapped, and after that, it's going to be back. So this is actually happening in the real time. So even so, it's me like keeping sense of agency, if it is moving my face and then the expression is all intact, but only identity is moving and then gradually changing over the time. So this is actually also like questioning about, okay, and then why is the self-boundary? Because like why we are talking myself, talking, having a chat, it's gradually changing my face from myself to other faces. In that case, like why is the self-boundary? So what point we cannot feel this is my face? Then we actually did some like experiment and the exhibition experiment in the National Museum, and we get the data of the how much that where is the moment they feel this is no longer my face. And we get the data or something, and then we actually find that this is kind of like a self-boundary of the moment of the many people started, oh, this is not my face. Right. And then that is kind of moment of the, pressing the button of the, this is not myself. And then 0 means like a kind of completed my face. And then 100 is more like for percentage of the other faces. So it's more like morphing to 1 to 0 to 100. And interestingly, also we are getting some data of the different gender and also different age group. And we actually find like a female and male, if we compare to the genders, the male has or female is more narrower sense of self-boundary, which is more for faster they find like this is no longer myself, which means like a self-boundary is actually narrower than the male. And also, when we compare to the age by age group, one like a 10s, 20s, 30s, 40s, we actually by kind of like as age go, like older than when we get the older, we have a much more relaxed sense of boundary. So it's also quite interesting because how individual difference of the self-boundary in this like a larger set of humanities. Right. So that's kind of the things we are also working on by because like, this is kind of a mixture of the identity and the actions and how you feel it. So this is another question of the new experiment. So we also doing something. But anyway, so that is a point because like knowing some self-boundary, self and the other, is actually also quite interesting because how that is actually telling us how we understand ourselves and also how people interact with each other, and also that's also quite might impact to the social interactions. So I will also let's talk about later. And also, using this as technology, we can also think of the very interesting situation of the action and the identity. For instance, you might see like this is a self face and then self face. So it's like just like a digital mirror, which is usual, right? So it's just usual. But for instance, here, this is actually the one person is actually moving another face. So you might find it. So this is actually that the action is intact, but identity is actually changed. And also, we can create another interesting phenomenon and the situation, which is like the facial identity is intact, but the facial movement and expression is mixed up together. So, for instance, in this video, two persons' face movement is mixed up into one face. Something like that. This is two faces. Then also like and then finally, this is also another example of the mixing up two faces movement into another face. So those things actually telling that like because by using these technologies, we can also decompose the facial identity and the facial movement. So the technologies actually make it possible to investigate more interesting way of the human action and identity in scientific way. So I will not go into go deeper, but by using these technologies, we also are investigating kind of like a science, kind of psychological, psychophysical experiment for like a cognition and also perception research by using new technologies. For instance, how these kind of visual motor synchronization will impact some self-identity, or is kind of having prior knowledge of the self or other, whether these kind of prior knowledge will impact some sense of agency. And it actually does. But then those kinds of technologies creates a new research paradigm to investigate in the human and of action, human in identity and of action. And like then coming back to the identity also like AI integration, maybe like because like I actually showed like one example of my AI created to myself. Maybe you might wonder like, oh, maybe like we can use that system for instead of myself and then doing some Zoom instead of myself, so we can do we can double our productivity, for instance, right? And then we actually tested we actually tested is it true or not. So this is also from the Kai 25, and by collaboration with Ife and CMU and Hiroshirado, and then Ife is a summer intern last year, by the way, from CMU. So in this experiment, we actually create like a audio agent, also the conversation experiment. And the task is kind of like a dual task. It's more like for two person is talking together, right? Remote partner and also local user is talking together. But still, local user, participant, have to doing some like a must task. Like you have to do work something. It's more like for like you can also easily imagine like even you are having some Zoom meeting together for other colleagues or something, but you have to still work on some writing an email, something like this. And then we actually create three conditions. One is no autonomy, which is like a no agent, no AI assistant, which is like our what we are doing, like in the naked bodies, like we have to do double work. So you have to talk to other person, but still you have to write an email, something like this. And we are actually using must task. And the full autonomy, we actually like create some voice agent, voice clone systems, which is like a AI can response completely instead of yourself. And then which means like this is actually the two person is sorry, one person, remote partner is talking to AI clone agent of the participant. And then actual participant, human participant is actually focused on the mass task. So it's kind of full autonomy, right? And the shared autonomy, which is an interesting point. Shared autonomy is like we can also still using AI agent, which is like instead of yourself, the AI clone, your clone agent can respond instead of yourself. But still, the participant can hear this response. And also, if he want to, or she or he want to cut into and override what the AI clone is talking about, we can actually like take over And then we can also like working on the mass task, which is like a kind of hybrid system of shared autonomy, right? The point is like he or she can still hearing some what AI clone, self clone is talking about. Then let me play the video of the example of the shared autonomy.
Yeah, I think like they'd make a good fit. Maybe like an interview with them personally would help better. But yeah.
So do you think they have the necessary skills and personality?
Oh yeah. So not the personality part, I'm not sure, but for sure their skills are up there and their motivation is up there as well. So it was a bit hard to gauge the personality from this.
What about their strengths and weaknesses?
Okay, so their strengths actually.
So something like this. So that is actually like the it's kind of partner and also user talking about some potential candidate to the PhD student or something, and then the user is also like working on the mass task, and then instead of a user, the agent also can talk instead of like ourselves. And then why is the result of this experiment? And then one thing, conversation quality and the number of the time taking and total was exchanges. It's actually surprisingly the no autonomy, which is like working on the full control, and the full autonomy, which is like an AI clone, completely take over the conversation and talking to the partner, and the shared autonomy. All the conversation, three conditions, having almost the same quality of the word and the conversation, which is actually like this system is working well, even though like full autonomy, right? And the point is like how was the mass task performance? And then, of course, in the no autonomy, this is actually they have to doing some your task. It's actually kind of not so much good. And full autonomy, yes, full autonomy because of the kind of person can focus on the mass task. Yes, it's kind of like a better performance. Problem and the interesting is like a shared autonomy. What will happen in the shared autonomy conditions? Here, it's actually in the shared autonomy conditions. It's actually quite worse and almost like a no autonomy, which is like a manual your task. So it means like a kind of there are no gain, no like a, no performance gain by using shared autonomy. Even even AI agents can take over the conversation. Right. Then interestingly, right, because like we actually also ask the participant and the current partners is like did you specify like who was talking? What was the counterparts like conditions? And then it's actually like a conditions matrix is telling that like people, you know, the partner not so much aware of the who was talking. It's very confusing. For instance, like even actual level of the code, a participant is using the shared autonomy, but still that they feel like, oh, this is actually like they no, this I feel like this is a 100% human. So this is actually the partners didn't notice like who is talking. It feels like a kind of almost like a random. It means the counterpart, the participant doesn't so much care about who is talking and they didn't notice. But like with interviews, we actually find like in this shared autonomy conditions, the participant is very kind of like kind of paranoid and also kind of like worry about how AI agents talking about. Right. So it's more for like because like AI is conversation as her or himself. So it means that the participant could not help to but monitoring whether it's actually consistent with themselves. So it's more like for like even we are applying these tools, it's more like for adding some new task. It's more like third task. It's more like working on the mass task and also like having some conversation and understanding the context, and also even in the AI monitoring some AI clone myself is consistent and aligned with me. So in that case, like this is actually quite interesting findings, which is like of course, AI clone, because in coming back to this data, partner is not so much aware of who is talking, whether AI clone or actual person is talking. It's not so much like aware of that. But the actual human is more aware and also conscious. They're a little bit curious about how he's talking about. So in that case, when we think about designing some AI clone system, if we design the AI clone system, which is still the actual human participant can monitoring this situation, it's actually going to be quite bad design of the AI clone, and which is we call alignment bottleneck. Right. So it's almost like human nature of the kind of interesting human nature because having some identity, keeping identity is actually sometimes having some like a kind of potential in the attraction of the attention actually. That's one thing. Right. So that's the one thing of the AI clone systems and also potential AI design. And then, right, so it's going to be like almost like a time's up. So first of all, I'm sorry, lastly, let me show our recent research outcome of the project. And then that is a funny picture of our team. If you closely watch this picture, you might find everyone has the same face. You might find, like, hope you can see, like everyone is having the same identity. It is actually using some swapping face technology, so like it's a little creepy. But by using the technology, we actually recently investigating about like on the social evaluation based on the identity. For instance, we recently like many psychological paper or some like social studies telling that like people tend to like or like, giving some like, social esteem or some like, giving some like, good or bad, and then if it looks like me, if it's similar to me, people more like to giving some esteem, like a good, like, and then something like this. So it's actually like there are many researches about like a similar person. If it's similar, they feel more familiar, something like that. But we actually challenge these theories, and then is it true or not? Then by using this technology to make face morphing. So this is actually, so this is in review, so please do not like share this research the materials because this is still in the review and not so much published. It's not published yet, but please not like disclose on the outside of the talk. And then this research we actually creating like a face morphing, which is 100% is like your face. And like people is watching two videos, let's say, participant watches the two persons videos, two persons talking each other. It's more like watching the YouTube video of the two persons talking together. And then participant task is like giving some like or dislike for these two persons. That's simple, right? So it's more like for watching the video and you see the two persons, and then then the participant like putting some like button or dislike button. But in the videos, we actually change the face of the person in the video by using facial morphing, facial swapping technologies. For instance, like you see, this is like a 100% yourself is a participant, and then 0% is like original person videos. So you might see that this is a face morphing, and like you participant see the video in the some video is actually morphing and swapped similar to yourself, similar to a participant, right? And the other control, we also using same video set and then other face condition, which is like a seeing the same video but not yourself, right? So it's just counterbalance. And like we analyze how people didn't dislike or like for this morphed person and also counter conversation partner. So you might see that this is kind of so this this is watching these videos, And then after the some like watching some 20 millisecond 20 seconds, the participant like asked to like putting like button or dislike button, something like this, right? Right, and then result. So in the if the let's imagine like this is the self view or other view. It's slightly not so much organized. But let's see. Imagine this is a participant face, and then participant face is more morphed target, and the target partner is not morphing and swapped. And then that's value is this is going to left. If you go to right, it's more like similar to participant. And then this axis 0 to 1 is more like for social likeness, which is like a probability of the holding like. And then we actually analyze our initial hypothesis is like if it's similar to me, people might rate the more like. So it should be something like this. It's going to bottom left to right top. But it's actually something like this. So some group of the participant is, of course, it's if it's similar to me, people more like to doing some like. If in the some participant group, if it's similar to myself, more for people less like less likely to doing some like. It's likely like a opposite. And what was these barriers? Is actually self-esteem of the participant. So that is important. Like in this self-esteem is like a self-esteem, like how much do they feel they like yourself, something like this. So, and then this value is of the participant itself. So if the participant likes themselves, they like more like person who's similar to themselves. And if the participant doesn't like themselves, but they will write less like less less like likeness for the target. Right? It's the opposite, and also like if it's like seeing the other persons, it doesn't like happening in the self differences. So it's actually only self face is actually matters. And also more surprisingly, and then because of that, we also getting data of the partner, which is not morphed at all, right? It's not morphed, not swapped at all, but we found same phenomena, which is like a participant who likes themselves, press like more on the partner who is talking with a person similar to a participant. It's kind of complicated, but it's more like for like it's propagated like those kind of social evaluations. And then like view it now. So this is actually telling that it's quite interesting phenomenon, which is like it's more like that's why we are saying like projecting esteem. Esteem is like a self-confidence or something. That if participants feel having some self-esteem themselves, they actually projecting their self-esteem to person who looks like yourself. And also this esteem is also projecting into the person who are talking with them. So it's more for projecting this self-esteem to projecting by a self-similarity and also social interaction, right? So this is also the very first step of the understanding the social interaction. But this is also telling that like why we formalizing some like a filter bubble or some like a echo chamber systems or some like a the social like kind of barriers. Because like it is telling that people who are having some self-esteem like more to people who looks like yourself and similar to themselves. It is actually forming kind of like a structure on the bubbles and in the circular systems, right? So it's more the first step to understanding why these kind of identity matters for formulating the social interactions. Right. So from this, so like I've stopped here, and then from this kind of project, I'm working on the the several research projects from the touching on the society, communication, identity, body, and actions. Right? And then to understanding these things, like eventually, it's going to be understanding not for the human nature, but also understanding human when we computer and human integrate. That is important to understand like these kind of structures, right? And like now, like in the larger scale, we are now trying to understand like enable humanity of the human computer integration, and also eventually the it's going to be like not only the human science, not only the science of the computer, it's going to be a science of human computer integration. That's kind of like a larger scale and larger the scope of our research. Right. So that's the end of my talk. And that's and the one thing, like in the Augmented Humans conference, will happen in the 26th, the March. It will be happening in the Okinawa, which is where I'm here, and in Japan. So if you have interest, and then please consider to submitting the augmented humans, and then we can also having like a chat and together for like a research discussion together. Right, so that's the end of my talk, and that's my contact and also some summary of my project video. So thank you so much for hearing, and happy to take any questions.
Great. Let's thank Shun. So that was a really amazing presentation, Shun. Lots of material there, and I guess there was more material you wanted to share, but it's on your slides. We'll be able to share later. So let me just see if there's any questions. Anybody in the room have any questions? Yep. Do you want to answer?
This is a very niche thing, but with the face morphing stuff, have you tested on anyone with prosopagnosia?
I'm not sure if you heard the question, but he asked, with the face morphing, have you tested on anyone with prosopagnosia? Is it prosopagnosia, which is that face blindness? Is it face blindness? Yeah.
Yeah. Thank you for giving. Unfortunately, we couldn't test these kind of the symptoms, the person with these symptoms. Yes, so it's quite interesting for like understanding, because like it could be interesting because those kind of facial, I forgot the name, but yeah, that's kind of symptoms. They could not identify the facial images as identity. But still, they might feel like an agency of the identity, right? Because like, they can also still understanding the motion matching of the facial movement or motion and the other person. So in that case, like quite interesting, because like in the whether they kind of like understanding identity might impact of the understanding the identity, the emotions, and also vice versa. So yeah, thank you. Unfortunately, I couldn't get a chance to doing that, but it's quite interesting. And also, unfortunately, not working with these symptoms, but we actually working on the person with ASD. ASD is like a autistic spectrum disorder. Then people is on my for instance, these people is less likely to having some difficulties to understanding human emotions, for instance. But by using this facial movement, also facial swapping technology, we can also investigate why is the difficult point of getting the emotions, because of the identity or because of the movement. Yes, so we are now working on those researches on the ASD persons. Hopefully, I think it's gonna be some connection to these questions. Hopefully, and then we are now getting the data. So maybe or hopefully next year we can also publish the paper.
That's a good question. Yeah. So I think he's saying that the face motion will be recognized, but the face expression, but you can still associate the face motion with your own face sometimes as well.
Yes, yeah.
Any other? So I had one question. I found your research on the perception of control of the robot was really interesting with the baseball bat. Saying that if you was able to map some of your body motion onto the baseball bat robot movement, then you assume that you're controlling the robot even when it was making the hitting by itself. I'm just wondering, have you done any work on virtual avatars in VR and AR? Because a similar thing happens, when you're in a VR and you're controlling an avatar, you're mapping your real body motion onto the avatar, but there's also an opportunity to have AI control of the avatar
Mhm.
as well. So have you done any work in that area?
Yeah, thank you. That is something we actually really want to do that. Unfortunately, we couldn't persuade this direction because like since we as a project we have to work on some like a robot itself. But
Yeah.
yeah, you're right. But because like that's quite interesting and also very nice opportunity to research those phenomena because like, sometimes the robot, so using robot for psychological experiment is quite hard. It's very hard to control. But if you can use those kinds of robot kind of like a virtual reality, I think this gonna be much more easy to operationalize. Yes, so I think that's quite interesting research project. But unfortunately, we didn't have a chance to do that.
It's okay. No, I can imagine that the similar lessons would apply. So if you have a virtual avatar, if it maps onto your gross body motion initially, then you assume you've got body control of the avatar. And then later
Yeah.
on, if you've got more AI control on the avatar, you might assume that you're able to dance better than you can, or maybe fight in a game better than you really can, or do
Hmm.
some
Hmm.
than really can. Yeah, that's really interesting. It'd be also
Yeah,
interesting
yeah.
to see what effect the mapping the face expression on the avatar would have if that, having a good face expression mapping assumes you've got better ownership of the avatar relative
Mhm.
to if avatar doesn't have much face expression mapping. Um, any other questions for Shun? So one question I had, and another one, I
Thank you.
found your Zoom experiment very, very interesting, where you are saying that if you
Mhm.
multitask, if you give the person an opportunity to take control over the agent, they actually perform worse than if they were applying full attention onto the other task. So that seems to have
Yes.
huge implications for a wide range of agent-supported activities. But I'm wondering, in this case, you're using a mathematics task. I'm wondering if you have any opinion about which tasks you think would have most impact in. Because mathematics may be involving different part of the brain than conversation. So I'm not, and so and when you're doing mathematics and doing conversation, then you're fully engaging with your brain. But there may be other tasks that where the same effect does not happen. So I'm not sure if you've explored a range of different tasks or just mathematics for now.
Yeah, yeah. Thank you for the question. Yes. So before jumping, before defining some task as a mass task, we actually investigate several potential tasks. But I think like when we doing some like a kind of language task, which is like writing the word or something, it's much get worse because it's a kind of conversation is also language task and the kind of thinking about the
Mm,
context and then writing the email is also like a language task. It's actually makes much worse if it's like
mm,
a
mm, mm,
same region of the task, I guess. Yeah, I guess like a task, the kind of the task might impact. And also replying to your answer and also like adding to your answer, I think this is also interesting, like a implication because we actually design these avatars or like an agent as their own, which is like a clone of the participant. And then if you design the slight different character of the participant, this might be different, but yeah, that's like an open question, I think.
mm. And Ashita had a question as well. Do you want to online? Do you want to unmute yourself, Ashita, and ask your question?
Yes, thank you so much for the great presentation. I had
Thank
a
you.
question about application of EEG in your research. Have you kind of explored understanding like neural signals while you're looking at the agency and embodiment aspects? Like, how does that complement with the behavioral data that you're collecting?
Thank you. So like easy things, like unfortunately, like we did our in our group we didn't do like any research of the EEG signal, but following up study is actually done by Pedro Lopez group, which is like a Chicago University. So maybe you can just find like if you can also find like a Google search of the Pedro Lopez and the EEG and the agency or EMS. Maybe you might find like they're working on the same experiment of the what we are doing. Like for instance, like let's say something like this. It's like quite simple. Like you see this kind of visual stimuli and you have to work, touch, and then also we apply EMS. And then as a success of this research, they are also working on the EEG of this phenomena. It's an experiment, and then they find like some kind of like these kinds of sense of agency on the time course is kind of correlated with event related negative event related potential of the EEG.
Right.
So it's gonna be like also like EEG could be like an interesting biomarker of the measuring sense of agency. But also same time, it's also quite very still controversial because the EEG signal, EEG analysis itself is quite like a noisy, and also we can only getting these cleaner images, cleaner data after the trial, many trials and aggregated data, which
Right.
means that we can only measure this sense of agency all after the trials.
Okay.
Yeah.
Right.
So like for instance, like if you can detect some agency measurement in real time, trial by trial, in that case, it's gonna be very interesting technology to think about like computer integration. But yeah, so EMG still have some like a kind of disadvantage of these kinds of measurement. Yeah, but challenging. Yes.
Yeah. Thank you so much.
Thank you.
And
Question.
Gun has a question online as well. Gun, can you unmute and ask questions?
Yeah, sure. Thank you very much. Thank you very much for the great talk. I have kind of two questions. First one is just clarification. One of your studies talking about self-esteem.
Sure.
Self-esteem, and when you resemble more than you like the person,
Yeah.
and also
Yeah. Yeah.
I might have missed it, but what kind of conversation topic were those in the video talking? Were they talking about negative things, positive things, or one were more aligned with the person watching? Can you give a little bit more
So
details, please? Thank you.
yeah, thank you, thank you. That is actually quite a important questions because like in this video, they this video is actually coming from the other data set of the data corpus, which is like already published. It's kind of like a like a research data corpus of the two persons talking, and then this data is more like for how to say self interaction each other, having a very natural daily chat. It's like a video corpus of the two persons first met and then talking themselves, and then also kind of like having some self interaction together or something, and then a little bit ice break something. But one interesting thing is like, and there are several kind of like a tone and also like positiveness or negativeness of the tone, the emotion or kind of like attitude of the videos. For instance, like some video is like a lot of they are talking very positively and then many laugh and then actually talking. And some video is kind of less awkward and then some silence and not so much active. So it's more. And like of course, those kinds like a sentiment of the video itself is also impact of this evaluation after these kind of things. But for instance, like these videos, those all data is actually aggregated to both sentiment, positive sentiment or negative sentiment. But yes, so like, of course, these kinds of holding like button is impacted by video sentiment. But even in this after the aggregation, we found the same trend, even in the same both good positive sentiment or negative sentiment.
Okay, great. Thanks for clarifying that. My other question was regarding the Zoom Zoom study that Mark was asking as well.
So
I understand you measured how much the other person were able to tell if they were talking to agent or
yeah,
hybrid or shared or full autonomous agent. When they later on realized they were talking to the agent, were there any indications of um, negative feeling about I'm kind of asking regarding the trust. When you talk to a
Yeah.
person, then there is a bit of a trust element there. Or was there any kind of social acceptance style of measures that you measured on the person talking to as
Yeah,
well?
yeah. Thank you. Thank you. That is actually quite good question, and also very that there are a lot of implication of this research, honestly. So one thing, because like, that those data, those kind of questions, we actually asked partner participant, all after the trials. It's more like they tried 3 trials, one in the random orders, and then do you think the first trial was AI clone or participant or something like this? And so that's why that means like but even they after that all of the trials, even after they found some of conversation was fully automated, they don't feel so much bad. In the conversation, they feel like, oh, yeah, we have a kind of a good conversation. Of course, in the task conversation itself is kind of like a structured because of some like a kind of avoiding some like a conflict of the more because the natural more like the coffee chat or something like a bar chat is more like important hard, but that conversation is kind of structured for the interview style, so it's more like structured, and then they feel like, oh, that was very natural, and then partner participant don't so much having some negative impression of the having a conversation with AI. But in the more like a negative feeling is actually on the participant side, which is like a person who are using AI clones because of the in the full automation points of the full automation system. This participant after the time we interviewed and they're also getting some questionnaires, right? They feel like a very feeling bad because like a partner is talking to microns and then doesn't mean it feels like, oh, I am deceiving him or
Teaching.
her. Yes, teaching her. So like that's actually yes. So like in the more for this negative feeling is coming from the local user, which is like a person who are using AI agent.
That's interesting. Thank you. Thank you.
Thank you.
Great, thank you. Any other questions? Any more questions online? And as I said, I've recorded the presentation and we'll get the slides later, so I'll share that with you later as well. So let's thank Sean again. Thank you so much, Sean. That was great.
Thank you. Thank you.
And it's amazing research. And then please, if you're a research student or interested, please connect up with the Augmented Humans Conference in
Please,
Japan.
yeah.
Yeah, we hosted it in Australia 2 years ago, and it was a fantastic event. So if you're doing work on human augmentation interfaces, then it's a great conference to attend, and Okinawa will be a great location. So thank you, Sean. We'll say goodbye, and I hope we can get a chance to meet face to face again. It's great.
Oh,
Thank you so
also
much.
one thing for sorry advertising. So we also doing some international internship
Oh
program
yes.
in CSL Sony Computer Science Laboratory and also OIS, which is Okinawa. So if you have any interest in doing some summer or winter intern, also please contact me and there is an email. So yeah,
That
that's
would
it.
be an amazing opportunity. Yeah, so definitely. Some of you in the room are PhD students or master students. So please think about doing an internship and visiting Japan. That would be incredible. That's great.